So what I have here is I have a standard form equation, and I want to know what the vertex is. I am not capable of just looking at this and saying, oh, the vertex is 4, -1, because it's not. When it's in vertex form, you can just look at it and know the vertex. But when it's in standard form, you cannot. When it's in standard form, you have some calculation to do. Now, the vertex is always going to be an ordered pair, right? Your first value in your ordered pair, the x value, you can get from -b over 2a. So let's do that. Negative, and what's b? 4 over 2 times what? 2, because that's a. Remember, here's a, here's b, and here's c, right? And so our x value will be -4 over 4, which is -1. So there's my x value. My x value in my vertex is also called my, say, line, axis of symmetry or line of symmetry. So if I ask for what is the axis of symmetry right here, you would have said x equals -1. That's your axis of symmetry. The value in your vertex is also your axis of symmetry. Okay, now we need the y value, don't we? So we're going to take that -1 and plug it into the equation. Y equals 2 times, and then I'm going to put -1 in for x, squared, plus 4 times -1 minus 1. So see, I took that -1 and put it in for x everywhere I saw an x. And so I had y equals 2 minus 4 minus 1. -1 squared is 1 times 2 gave me 2. 4 times -1 gave me -4, and then here's a -1. 2 minus 4 is -2 minus 1 is -3. So there's my vertex. This is vertex form. The beauty of vertex form is we can just look at it and tell the vertex. That's why it's called vertex form. Where standard form, we cannot just look at it and know the vertex. But in vertex form, we can. So the vertex is going to be an ordered pair, right? And so for the first value, you say, what will make x minus 3 0? What number can I put for x? 3. 3 minus 3 is 0. So that's the first value in your vertex. And the second value is whatever is outside the parentheses right here. So what is it?
7.
7. Boom. I'm done. There's the vertex. So here we want to calculate the vertex, don't we? Okay, this is a standard form equation, so I am not able to calculate the vertex here just by looking at it. So I'm going to write my parentheses, and I know the first value in my vertex is -b over 2a. That is also the axis of symmetry. So I'm going to do -b over 2 times a, right? Now 2 is understood to be over 1. So I'm just multiplying the top. So here I got -9. And then I'm multiplying the tops, which is 6. And the bottom, which is 2. Well, what is 6 over 2? 3. So this is -9 over 3, which is? -3. So my axis of symmetry is -3. Right? But I don't know the y value, do I? To find the y value, I'm going to put it in for x right here, and I'm going to put it in for x right here, aren't I? So let's do that. So I have y equals 3/2, and in the place of x, I put a -3 all squared, plus 9 times -3 minus 2, right? So I have y equals -3 squared is 9. And 9 times 3 is 27, divided by 2 is 13.5? Is it 15.5? So I got 13.5 plus -27 minus 2. And when you type all that in, what does y equal? -15.5. And so right here I have -15.5. And so this whole thing right there is the vertex. Okay, so on this one, we also want to find the vertex. This one is in vertex form, which makes our job much, much simpler. All we have to do is look inside the parentheses and say, what can I put in for x to make what's in the parentheses 0? So what plus 5 equals 0? -5, and so that's the first number in your vertex. And then whatever's outside the parentheses is the second number. And so boom, I have the vertex. This is why we like vertex form, because finding the vertex is very, very simple, isn't it? So what you should have learned is that if we have a standard form equation, finding the vertex is different than if we have a vertex form equation.